In the vast cosmos of artificial intelligence, there lies a powerful tool that can decipher the intricate patterns of the universe. They call it convolution neural networks. Imagine a world where machines can see and understand visual information just as we humans do, or perhaps even better. This is no longer a figment of science fiction, but a reality we live in, thanks to the advent of convolution neural networks, fondly abbreviated as CNN. CNN is a class of deep learning techniques that has revolutionized the field of artificial intelligence, particularly in the domain of image processing. These networks possess the unique ability to automatically and adaptively learn spatial hierarchies of features directly from data. But what does that mean in layman's terms? Well, imagine you're looking at a picture of a cat. Your mind doesn't just see a random collection of pixels, it identifies shapes, patterns, and features that collectively form the image of a cat. That's exactly what a CNN does, but in a much more systematic and mathematical way. Starting from the basic elements like edges and colors, a CNN gradually learns to recognize more complex patterns and shapes. By the time the information reaches the final layer of the network, the CNN is capable of identifying the image as a cat, a dog, a car, or whatever the object might be. CNN's ability to process complex data has made it an invaluable tool in a variety of fields. From medical imaging to autonomous vehicles, from facial recognition to video surveillance, the applications of CNN are as diverse as they are impactful. As we delve deeper, we uncover the immense potential of convolution neural networks, an artificial eye that perceives the world in a way that transcends human understanding. Imagine a tool that could detect cancer cells with more accuracy than the human eye. It's not science fiction, it's the reality of convolution neural networks. Convolution neural networks, or CNNs, have been making waves in the field of medical diagnosis, particularly in cancer detection. These sophisticated algorithms are capable of analyzing medical images and identifying patterns that may not be visible to the human eye. Take, for example, the case of Google's lymph node assistant, fondly known as Lina. This artificial intelligence tool was trained using CNN to detect breast cancer. The results were astounding. Lina outperformed human pathologists by identifying cancer cells with a higher degree of accuracy. So how does it work? Well, CNNs use a series of filters and mathematical operations to transform an image into a form that the network can understand. These networks have the ability to learn and identify intricate structures within the image, such as the subtle differences between cancerous and healthy cells. But it's not just about identifying cancer cells. CNNs can also help in grading the severity of the disease, determining the best course of treatment, and predicting patient outcomes. This could mean the difference between early detection and effective treatment versus late-stage diagnosis and limited treatment options. The use of CNNs in medical diagnosis is not without its challenges, of course. These tools require vast amounts of data to be effective, and there are privacy concerns related to the use of patient data. But the potential benefits in terms of improved accuracy and early detection are significant. The world of medical diagnosis is changing rapidly, and CNNs are at the forefront of this transformation. They are helping to streamline the diagnostic process, reduce human error, and ultimately save lives. And so, thanks to convolution neural networks, a brighter future in medical diagnosis is not just a dream, but an unfolding reality. What if you could sit back, relax, and let your car do the driving? With convolution neural networks, this is no longer a mere fantasy. Imagine a world where the tedious, often monotonous task of driving is completely automated. This is the world that convolution neural networks, or CNNs, are helping to create. In the realm of autonomous vehicles, CNNs play a critical role in image recognition, object detection, and path planning. Let's start with image recognition. CNNs are used to interpret the visual world around the vehicle, just like a human driver would. They can identify different elements of a scene, such as roads, traffic lights, and pedestrians. This interpretation helps the vehicle understand its surroundings and thus navigate safely. Next, we have object detection. CNNs are able to recognize and locate objects within these images. For instance, they can detect a pedestrian crossing the road or a car abruptly halting in front of them. This ability is vital for the vehicle to respond appropriately to its environment, ensuring the safety of its passengers and other road users. Lastly, there's path planning. CNNs can predict the path that other vehicles or pedestrians might take. This predictive ability allows the autonomous vehicle to adjust its own path accordingly, avoiding collisions and ensuring smooth navigation. But how does this work in reality? Let's take the example of Tesla's autopilot system. It uses CNNs to interpret the visual data captured by its 8 surround cameras. The system can recognize and respond to stop signs, traffic lights, and other vehicles. It can even navigate complex intersections and tight parking spaces. All this is made possible by the power of convolution neural networks. So as we delve deeper into the era of artificial intelligence, our roads are becoming smarter and our commutes more relaxed. We're no longer just dreaming of a future where we can read a book or take a nap while our car drives us to our destination. We're building it. Thus, with convolution neural networks at the helm, we're steering towards a future where cars drive us rather than the other way around. Your face is your password. A concept that seemed far-fetched years ago is now a reality thanks to convolution neural networks. Delving into the realm of facial recognition, we find that CNNs are the invisible force behind this technology. They are the reason why your smartphone recognizes you in a fraction of a second, unlocking a world of convenience and security. But how does this happen? Imagine a bustling city, full of unique buildings and landmarks. Just like you would navigate this city using these landmarks, a CNN navigates a face using its unique features. It starts by scanning the image of a face pixel by pixel, identifying the edges and shapes that make up the facial features. This process is the convolution in convolution neural networks. For example, consider Apple's Face ID technology. It uses a CNN to analyze the facial data captured by the TrueDepth camera system. The CNN then creates a mathematical model of your face, encoding your unique facial features into a string of numbers. This digital signature is your Face ID, and it's as unique as a fingerprint. When you look at your phone, the Face ID system captures a new image, runs it through the CNN, and compares the result with the stored digital signature. If the two match, voila, your phone unlocks. But the impact of CNN in facial recognition extends beyond our smartphones. It's revolutionizing security systems, making them more robust and less prone to errors. It's also being used by law enforcement agencies for identifying suspects and by retailers for personalized advertising. The power of CNNs in facial recognition is not just about convenience, it's about creating a safer and more personalized world. It's about transforming the way we interact with technology and with each other. With convolution neural networks, we are not just unlocking our phones, we are unlocking the future of security. From diagnosing diseases to driving cars and recognizing faces, convolution neural networks are transforming our world in unimaginable ways. They're the powerhouse behind many technological advances we see today. In the medical field, they're revolutionizing diagnoses, making them more accurate than ever before. On our roads, they're at the helm of autonomous vehicles, driving us towards a safer future. And when it comes to recognizing faces, they're the invisible force that powers many of our security systems, making them more robust